So if we have a proportion or fractions that equal fractions, what is our first step? Cross multiply. So 5 times everything here, 2 times everything here, and rewrite that. Whether you put this on the left or right does not matter as long as they're set equal to each other. And then our next step. Okay. On both sides at the same time. 5x minus 10 equals 2x minus 16.
So if we, could we just jump to that part?
Yes, yes, you can. Alright, and then take something you want to move. Let's say I move 2x over here. That's not what you did. It's okay. There are 4 different ways to go about doing this. And I move 10 over. So we have 3x equals negative 6. Divide both sides by 3. So x equals negative 2. Remember that while you're practicing, you can use Desmos, you can check your answer, you could put it back in, do it algebraically, and see if they're the same on both sides. Do you have any questions on that one? For number 5, going back to your simplifying radicals, so we need to do order of operations. So multiply first the outsides together and the insides together. Bring down your negative 2 root 7 plus 8 times 28. Then we could simplify the square root of 28. How you did that does not matter. If you use the square root, the highest perfect square that could go into 28 is 4. And then the square root of 4 is 2. So we would bring everything else down. Multiply the 8 and the 2. And then if we have like terms, the same number inside the radical, the radicand, we would add the 2 numbers on the outside. So negative 2 plus 16 times the square root of 7. Our final answer for that one. Questions on that one? If you are not at your seat, go back to it. And today we're going to be talking about the last objective before you guys take your quiz and test. Not next week, but the week after Thanksgiving break, we're going to be taking our quiz and test. So if I asked you, what is the difference between these two sentences? Yes, this is circle, but this is for that. What is the difference? Okay, so yes, but then what does that mean? Alice?
It means that it's absolutely true.
So one is there are actual cats and dogs falling out of the sky, and then the other one is an exaggeration. It's raining so hard it could be like cats and dogs are raining out of the sky. So here are more examples of literal. Sometimes when we say, I got your back, we're not implying that we're holding their spine in there. So, yes, literal does mean actually or without exaggeration, but we are going to be talking about literal equations. So when we talk about literal equations, those equations have more than one variable, and we're going to solve them just like normal equations, but we are not going to get a numeric answer. We're going to have an equation with just just variables, actually solving the equation, but to not get an actual number. So when we get it, it'll look something like, maybe there'll be a number here, maybe there won't. Any set of numbers could be put in there if we knew information, but we don't, and we're not going to be given that. So, go to the next page. So, we are going to solve regular equations, get a numerical answer, and then we're going to have a literal equation with just variables where we will not get a numeric answer, but it'll be solved very similarly to the regular equation. So for this first one, how would we solve it for x? How would we get x by itself? Matthew?
You would divide 2 by 10.
So x equals 5. If I put that back in, 2 times 5 is 10. That works. Now, think about that same setup. In example 2, we are now solving this equation for h. How would we do that? Victoria? Divide both sides by g. And when we do that, the g's cancel, leaving just h, but then you have m over g. So we are not going to have any numbers, but that would be the answer to this equation. If we had numbers to put in, we could figure out what h actually equals, but we don't. Do we have any questions on that one so far? Look at example 3. We are solving that one for x. What would we do first? Go ahead, Victoria. Subtract the 5. We have 2x equals 6. And then just like that last problem, we would divide everything by 2. So that's something we could put back in. 2 times 3 is 6. 6 plus 5 is 11. That works. Now looking at example 4, how would we solve that? Matthew?
Subtract b.
But when we subtract b, c and b are not like terms, so we're not going to combine them. We're just going to move the b to the other side. We have ax equals c minus b. And then, if we're trying to get x by itself, what would we do? Matthew, go ahead.
Divide
So we're going to divide this entire thing by a and this side by a. These a's would cancel, and you'd have c minus b all over a. So sometimes you'll look back at these answers like, what are we doing? Solving equations without numbers.
Well,
Make sure here are your notes. Do we have questions so far? Look at example 5. Now it has numbers and variables, but it has 2 different variables. We're trying to get x by itself. What do you think would be the first step? Alex?
Adding 6y to 17.
So even though it has two variables, we don't need to do anything with the y. We don't need to separate it. We don't need to divide or anything like that. We can just get rid of it because we don't need it by moving it to the other side. So we have 3x equals 17 plus 6y. Go ahead, Matthew.
You can divide by 3.
Because these are numbers, though, we have to divide every single thing by 3, because some of the numbers could simplify, some of them could not. It depends. So x equals 17 over 3 plus 2y. What questions do we have so far?
Well, can you explain the dividing?
So before, when we were just dividing, we didn't divide it to like every single piece because nothing would cancel, nothing would simplify. But here, because I know 3 goes into 6, I would want to divide each thing separately so that I know that these would simplify. Right? We are going to stop there, and then when we come back, we are going to do number 8. So look at example 5. It's very similar, but now we just have variables. How do you think we would start solving this one? So look at example 5. Look at how we started that one. It's going to be similar for 8, but we just have variables. How would we start it? Destiny? So we're solving for A. We got to get rid of the CD term to subtract that to the other side. Again, these are not like terms. We cannot combine them, so we're really just moving it over to the other side. And then to get A by itself, Lily?
Divide B.
So we would do that to everything here because nothing is a B, so nothing would cancel or simplify. So A equals G minus CD all over D. Do we have any questions about that one? I want you to try examples 6 and 7, and then we'll come back and talk about them. If you find the answer, or when you have both answers, raise your hand. If you need to see the works, then we'll go back and do that. So for number 6, the answer to this was y equals negative 17 over 6 plus 1/2 x, or plus x over 2. Do we need to see that one? Do we have any questions about that one? Especially when you have numbers, make sure you're dividing everything because something could simplify unless you know for a fact that nothing could simplify. So like if it was 17 and 13, then you wouldn't need to divide everything, divide each piece. Right, for number 7, the final answer was C equals G minus AB all over B. Anyone need to see that one? On the next page, find any questions you want to see, go over, have questions about, aren't sure where to start. Three. Cameron, see? Any others on that page? Lily?
5.
anything else on that page? So let's start with number 3. We are trying to solve or get what by itself? F. So here, the F is inside parentheses. We need to somehow get it out. We could do that. However, if we distributed, we'd end up with 5/9 F. We'd have some weird fraction here that we'd have to deal with. And then we would still have to get rid of the 5/9 eventually. What could we do instead of distributing? By what? Okay. Instead of dividing by a fraction, what would we do instead? Because that's not technically wrong, we just wouldn't write it like that. Lily? Multiplied by, not by 5/9, by 9/5. So take it and flip it. Multiply by the reciprocal is what that's called. Multiply that on both sides. So then what happens is the 5/9 and the 9/5 cancel. And then we have 9/5 C. The parentheses will drop. Now how would we solve for F? Add 32 to both sides. Again, these are not like terms, so we cannot combine them. We're just putting them next to each other. So 9/5 C plus 32 equals F. This is a real equation or formula. It's converting Celsius and Fahrenheit degrees back and forth, if you're curious. So that would be our final answer. Do we have any questions on that one? For number 5, we need to get B by itself. We need to get rid of C, get rid of D. What would we do first? Multiply by what? When you do that, think about the B and C like they're in parentheses and not actually multiplying it to that so that the D's cancel. Whether you write AD or DA does not matter. And then to get B by itself. So DA minus C equals B would be our final answer. Questions on that one? For number 6, we're trying to get B1 or B sub 1, however you want to say that, by itself. Right now it's in parentheses. This will be similar to 3, number 3. So what would we do first? So with that, it would be 2 over 1 or just 2. Multiply that on both sides. So the 1/2 and the 2 cancel. We have 2a equals h times b1 plus b2. But now what? Lily? If we distribute it, we have to eventually do something to get rid of the h by the b1. What can we do instead? Hannah? So 2a over h, now the parentheses drop, b1 plus b2. And now we can get rid of b2 by subtracting. So 2a over h minus v2 equals v1. Would be our final answer. As long as you keep whatever you're trying to get by itself in your mind and don't start solving for something else and think about how you would solve a normal equation, you should be fine. Do we have any questions on that one? Look at the next page. Find any questions you want to see, go over, have questions about, not sure how to start. Number 7. Okay, Cameron? 4. Any others? Cameron? 5. Nature? 8. Any others? Lily? 1. Nature, are you raising your hand? Okay. Alright, so let's start with number 1. If we're trying to get t by itself, what is I, r, and t doing to each other? So to undo that, we would divide, but all at the same time, I and r on both sides. So we have t over IR equals t. Questions on that one? For number 3, we are trying to get x by itself. So we need to get rid of what? By doing what?
By adding.
To the other side. We have y plus 6 equals 5x. And then, because this is a 5, the number in front of y is a 1, and this is a 6, nothing would simplify, so we can just divide everything by 5 all together. If this was like y plus 10, then we would divide each one separately. Do you have any questions on that one?
So does it matter if the 6 and y are like switched?
No, it doesn't matter. If it was subtracting or dividing, yes, the order would matter, but adding, no, it doesn't. Alright, number 4, we are trying to get m by itself. What would we do first? So the 2's would cancel. We have 2k equals mv squared. M is being multiplied to v. V is being squared. So we just need to get rid of v squared. How would we do that? Not cube. I think you're thinking square root, but we don't need to do that because we're not solving for v. Anna? Not by 2, but by v squared. So 2k over v squared equals m. If this problem asks you to solve for v instead of for m, we would have divided both sides by m and then taken the square root of everything, which we'll do here in a moment. For number 7, that's pi r squared. So if we're trying to get r by itself, what would we do first?
Minus pi.
Say that again.
Minus pi.
Not minus. We're going to do something for pi though. Mm-hmm. Because these are multiplying. So my pi symbol is not that great. Make yours look however. So we have a over pi equals r squared. Now if we're trying to get r by itself, what would we do? So take the square root of both sides. And what happens is the square and the square root cancel each other out. So the square root of a over pi equals r. So it depends on what the problem is asking you to find. If it was asking you to solve for pi, you wouldn't take the square root. It depends. Do we have any questions on that one? Right, and then this last one, we are trying to get x by itself. So right now, x is negative, it has a negative coefficient, and we need to get rid of the j term. So subtract that over. Think about your standard form, rearrange them so that they are in standard form, ABC order. If I were to divide by -4, would any of these simplify? Would 2 over -4 simplify? Yeah. So we're going to divide each number by -4. So this would become -1a over 2 or -a over 2, either or -1/2a, however you want to write that, plus 3j over 4 or 3/4 j, either or, does not matter, minus 9z over 4 or 9/4 z equals x. Both of these are the same thing, but it's written differently. Do we have any questions on that one? Turn the entire set of notes to the back so it's a blank page. I'm going to show you 2 of the examples you might see on the Khan Academy that is due on Tuesday, not next Friday. How did you do what? We just rearranged them to put it in standard form. Okay, so I'm going to show you how to do these because it's a little bit more complex than what we would do. But if you can do these, then you'll be great for the quiz and test. So go ahead and write this down. Negative px plus r equals negative 8x minus 2. When you see these type of problems, you want to get whatever it's being asked to solve for, so in this case x, all of your x's on the same side, anything that doesn't have an x on the other side. So it does not matter if I move this x term over here or this x term over here, doesn't matter. So let's say I add.
Where is my?
Hold on. There we go. Okay. It was letting me draw earlier. But it's gonna lag really hard. So if I move 8x over, I would be getting rid of the r to move it to the other side. So it would look like negative px plus 8x equals negative 2 minus r. Did it work?
Did you send it to me? Because I don't see anything.
And then once you have all of your x's on the same side, this next part is a little bit of something we'll do later, but we're going to undistribute. So think about when you distribute, you usually have something outside of parentheses and then we multiply it to everything. We want to undo that. We want the x term to be outside of everything here. So we're going to take it out of everything that's here. Later we'll call that factoring. And then when we take it out, we're dividing each of these by x to see what's left. So when we do that, this one would become negative p, this one would become positive 8. And then because we're trying to get x completely by itself, we're going to take what's inside the parentheses and divide both sides by that. So this fraction is what your answer is going to be.
Minus r over negative plus 8.
So all of these answers are going to be fractions of some sort. This is one type of equation you may see. What questions do we have about this?
Why did you put the R on the other side?
I don't need it over here since I'm just focusing on my x's. So anything not related to x, I need to get rid of it. Move it to the other side. I think it said satellite office. This is SAP office. Yeah. You want me to? It's up here. We're almost done with this, but it's up here. Right? Any other questions on this? Okay, I'm going to show you one more example. So that last type, we didn't have parentheses. We eventually put parentheses in. This type, you would be given parentheses. So if you can't see this, this says W times negative 4 plus Z equals MZ plus 17. Because in this problem we're trying to get Z by itself, and we have Z inside these parentheses, we want to distribute before anything else. So distribute the W. Lily, I think you're coming back. I think you're coming back. And then we're trying to get all the z's on the same side, so now it becomes just like what we were doing before. I can move this over. Doesn't matter, I could have moved WZ over as well. And then I'm going to get rid of this 4W because I don't need it by adding it to the other side. And then I'm going to rewrite everything. So WZ minus MZ equals 17 plus 4W. Just like before, we're trying to get that Z outside of parentheses, so it's by itself. So we're going to take it out, divide both of these and see what's left. So for this one, it would be W. For this one, it would be negative M. And then we would divide both sides by what's inside the parentheses. So our answer is going to be this fraction right here.
If I can get to it. 17 plus 4W all over W minus M.
So the type of problem depends on whatever you get. You'll either have parentheses or you won't. Sometimes you'll have 3 terms with the same variable, like 3 things with Z or 3 things with X that you'll all need to move to the same side, but the process is the same. So this is the one that is due Tuesday. If you want to work on that so you don't have to worry about it next week, you can get that done today. You can do that. If you need my help, you can let me know. If you haven't done the Khan Academy that's due tomorrow, you can be working on that. I'm going to pass out a review. So you can be working on Khan Academy, the review, or more practice problems from the notes that we just done. But be actively working on something.